Hello everyone, today is January 14th. Today we're going to be working on these Newton's second law practice problems. We have our bell ringer in our folder here. If we select our bell ringer and click start new attempt, we will see we have 4 questions here. A force is a blank on an object. Our options are push, pull, neither, or push or pull. We've learned that a force is a push or pull, so that is the correct answer. Number 2, Newton's second law of motion can be stated as an object at rest stays at rest, an object in motion stays in motion unless acted on by an outside force. So that one sounds like Newton's first law, so that's not the correct answer. B, the greater the mass of an object, the more force it will take to accelerate the object, or F equals ma. That one sounds pretty correct, so I'm going to keep B in mind here. C, for every action there is an equal and opposite reaction. That one doesn't sound correct. And D, opposites attract. So the correct answer, we are going to go with B, since that is our best answer. Question 3. Acceleration is slowing down, speeding up, changing directions, or all of these. We've learned that in science terms, acceleration is all of the ups. And our last question is, as the mass of an object increases, its acceleration decreases. So as it gets heavier, it goes slower, and that is true. So once you submit your bell ringer, we'll go back to our Schoology folder here. We have our flashcards. You can study these at your own convenience. And then we have our practice problems. So we are going to go over this in class, but if you are not here today, please feel free to just write these down on a piece of scrap paper and turn them in when you come back. So I've copied these to Notability so that you guys will be able to see what I see and see what's on the paper that's listed on Schoology. So again, you can just write them on a piece of scrap paper and that will be fine. Our directions for each problem show how you arrived at the answer. So we need to show our work. If we start here with number 1, a skateboard has a mass of 3 kilograms and accelerates at a rate of 5 meters per second squared. Find the amount of unbalanced force. So I'm going to set this up with our F, our M, and our A because we have our formula F equals ma. So we are looking for the force here, so we are not sure what that is. We have our mass of 3 kilograms, and our acceleration is 5 meters per second squared. We are simply going to plug in our numbers to the formula and solve. So F is equal to our mass, which is 3, times our acceleration, which is 5. 3 times 5 gives us 15, and we're going to want to make sure we put our N for newtons on there. Number 2, if a force of 4 newtons moves a paper airplane with an acceleration rate equal to 8 meters per second squared, what was its mass? I'm going to do the same thing over here. We know our force this time. Our force is 4. We know our acceleration, it is 8 meters per second squared, and we are looking for our mass. So using our formula F equals ma, we are going to plug in our numbers. We have 4 for F equals m, which is what we are looking for, times 8, which is our A. To get our m alone, we're going to do the opposite of multiply by 8, which is divide by 8. And then we are going to simplify our fraction. Since these cancel out, we have m equal to 4/8, so m is equal to 1/2, or we can say that is 0.5. And we want to make sure we have our unit in there of grams or kilograms. Number 3, if a 2 kilogram paper airplane is pushed by the wind with a force of 5 newtons, how fast will the paper airplane accelerate? So again, we have our force. It is 5. We have our mass, which is 2. And we are looking for the acceleration. So when it comes to our formula, we are going to plug in our numbers. F is equal to 5. M is equal to 2. And we are going to multiply that by A. To get our A by itself, we're going to do the opposite of multiply by 2, which is divide by 2 on both sides of the equation. Cancel out our 2's. So A is equal to, if we simplify our fraction, that is 2.5 or 2.5. And our unit for this is meters per second squared. Number 4, a bird has a mass of 6 kilograms and accelerates at a rate of 7 meters per second squared. Find the net force. So we are looking for our force this time. Our mass is 6 kilograms and our acceleration is 7 meters per second squared. Using our formula F equals ma, we are looking for our force, we know our mass, and we know our acceleration. So our force is equal to 42 newtons, because 6 times 7 is 42. Number 5. If an object's mass is 65 kilograms and it accelerates at a rate of 2 meters per second squared, how much force was applied? So once again, we have F is what we are looking for. Our mass is 65 kilograms and our acceleration is 2 meters per second squared. We are going to plug in our numbers to our formula, F equals ma. We are looking for F. We have 65 times 2. If you need to use a calculator, feel free to do so. I don't think I have one installed on my iPad. I know that 65 times 2 is 130, and that is newtons for force. Number 6. We have find the net force of a 240 kilogram vehicle accelerating at a rate of 4.5 meters per second square when it hits a wall. So we are looking for the force. We know our mass of our vehicle is 240 kilograms and our acceleration is 4.5. So F equals ma. F is equal to 240 times 4.5. Oops. F is equal to, let me grab a calculator here, 240 times 4.5 is 1,080, and our newtons are our unit of force. Our next one, find the acceleration rate. If the force is 200 newtons and the mass is 150 kilograms, F equals ma is our formula. F is 200 equals 150 times A. Divide both sides by 150. Again, I'm going to use a calculator because that's a little too much for me. We have 200 divided by 150, and we get 1.3 meters per second squared. Number 8, what is the acceleration rate if the force is 170 newtons and the object's mass is 25 kilograms. So we are looking for A. Our formula, F equals ma. F is 170. Mass is 25 times A. Divide both sides by 25 to cancel out. 170 divided by 25 is 6.8. A equals 6.8, and our unit is meters per second squared. Number 9. What is the amount of unbalanced force is needed to accelerate a 10 kilogram crate of strawberries at a rate of 3.5 meters per second squared? So our force is what we are looking for this time. Our mass is 10 kilograms, and our acceleration is 3.5 meters per second squared. So using our formula, F equals ma, we have F being what we are looking for. Our mass is 10, and our acceleration is 3.5. So 10 times 3.5 is 35, and our answer is newtons because we are looking for the force. Number 10. Find the mass of a golf ball cart that is accelerating at a rate of 6 meters per second squared and has a force of 342 newtons. So we have our force of 342 newtons. Our mass is what we are looking for, and our acceleration is 6 meters per second squared. So using our formula, F equals ma, I know F is 342. M is what we are looking for, times 6. To get our m by itself, we're going to divide both sides by 6. 342 divided by 6 is 57. So our mass is 57 grams. Number 11, a truck has a mass of 5,000 kilograms. The truck driver presses on the brakes. The unbalanced net force acting on the truck when the brakes were applied was 6,000 newtons. What is the truck's acceleration? So we know the force. It is 6,000 newtons. We know the mass, which is 5,000 grams or kilograms. And we are looking for our acceleration this time. So F equals ma is our formula. We plug in our numbers. 6,000 is equal to our mass, 5,000, times our acceleration. We divide both sides to get A by itself. And A is equal to 1.2 meters per second squared. Number 12. Find the mass of the object if the force acting on it was 300 newtons and the acceleration rate was 9.8 meters per second squared. So we have our force this time, which is 300 newtons. We have our acceleration, which is 9.8, and we are looking for the mass. So F equals ma is our formula. F is equal to 300. So 300 equals m, because we are looking for the mass, times 9.8. We want this m by itself, so we're going to do the opposite of multiplying, which is dividing. So divide both sides by 9.8. This cancels out over here. And 300 divided by 9.8 is about, oops, it's not acceleration, it's mass. The mass is approximately 30.6 grams. What is the force needed to accelerate a 144 kilogram cart at a rate of 2.5 meters per second squared? So we are looking for the force again. We have our mass, which is 144. And we have our acceleration, which is 2.5. So F equals ma. F is equal to our mass, 144, times our acceleration of 2.5. So 144 times 2.5 is equal to 360. And our answer is in newtons. Number 14. The cyclist has a mass of 50 kilograms, is accelerating at 0.9 meters per second squared. What is the amount of net unbalanced force? So we are looking for the force again this time. We have our mass, which is 50 kilograms, and our acceleration, which is 0.9 meters per second squared. So F equals ma. Our force is what we are looking for. Our mass is 50 times our acceleration, which is 0.09. 50 times 0.9 is 45. So F is equal to 45 newtons. Number 15, what is the mass of the object if the net force acting on it was 356 newtons and the acceleration rate was 4 meters per second squared? So we have our force of 356 newtons. We are looking for the mass, and our acceleration is 4 meters per second squared. So our formula, F equals ma. 356 is our F. We are looking for our m, and our a is 4. We're going to divide both sides by 4 to cancel it out. On this side, get our m all by itself. 356 divided by 4 is 89. And we'll just throw grams on there and assume our unit. Number 16, this will be the last one we'll go over for today. We have two forces acting on a parachutist during a drop. Net force is 550 newtons. The parachutist has a mass of 100 kilograms. What is the acceleration of the parachutist? So we have a force of 550 newtons. We have a mass of 100 kilograms. And we are looking for the acceleration. So F equals ma. Our F is 550. Our mass is 100. And we are looking for A. So we are going to divide both sides by 100 to get the A by itself. And A is then equal to, I always cross them out to show that they are canceling each other out, the zeros at the end. 55 divided by 10 is 5.5, and acceleration is meters per second squared. So that is as far as we got in class today. We will finish the rest on Tuesday when we come back from our long weekend. I hope you guys have a great and safe weekend and stay warm with all the